Have you ever stopped to think about why Earth is so perfect for life? How our planet has just the right atmosphere, temperature, and day-night cycle for living creatures like us? Let's dig in. Earth's journey to becoming the ultimate oasis for life is a tale billions of years in the making. It starts with the formation of our atmosphere. About 4.6 billion years ago, Earth began to form through the accumulation of cosmic dust and gas. The heat generated from the intense pressure and impacts of collisions caused the release of gases like water vapor, carbon dioxide, and nitrogen. Volcanic eruptions also played a key role, spewing out even more gases. But the early Earth wasn't so welcoming. The atmosphere was mostly made up of methane and ammonia, which would be toxic to us today. So, how did we end up with the life-sustaining air we breathe now? Cyanobacteria, tiny photosynthesizing organisms that transformed our planet's atmosphere. These microscopic heroes started producing oxygen about 2.4 billion years ago, creating an environment suitable for more complex life forms to evolve. Okay, so we have an atmosphere. But what about Earth's perfect temperature? How is it that our planet has just the right conditions for liquid water and life as we know it? It's all about location and location. Earth sits in the Goldilocks zone, the habitable region around a star where conditions are just right, not too hot, not too cold, for liquid water to exist. Our planet's distance from the Sun, combined with its size and composition, allows it to maintain a stable temperature. But Earth's temperature isn't just regulated by our position in the solar system. Our atmosphere also plays a vital role in keeping things comfortable. Greenhouse gases, like carbon dioxide and methane, trap heat and keep our planet warm. This greenhouse effect is essential for life, but too much can lead to runaway global warming, as seen on Venus. Now, let's talk about our day-night cycle. Why do we have a 24-hour day, and how is that perfect for humans? The Earth rotates on its axis, completing one full turn every 24 hours. This rotation creates the cycle of day and night we're all familiar with. But it wasn't always this way. Early in Earth's history, days were much shorter, around 6 hours long. So, why did Earth's rotation slow down? The answer lies in a dance between Earth and our closest cosmic companion, the Moon. The gravitational interaction between Earth and the Moon causes a transfer of angular momentum, slowing down Earth's rotation and pushing the Moon away at a rate of about 3.8 centimeters per year. This process has lengthened our days, giving life on Earth time to adapt and thrive. But the story doesn't end there. Earth's unique combination of factors like plate tectonics, a strong magnetic field, and the stabilizing influence of the Moon make our planet even more special and perfect for life. Plate tectonics are the large-scale movements of Earth's lithosphere, the rigid outer layer of our planet. These massive plates move, collide, and separate, shaping the Earth's surface over millions of years. Plate tectonics are responsible for recycling essential nutrients through a process called the rock cycle. They also help regulate our planet's temperature by removing and storing excess carbon dioxide from the atmosphere, preventing the runaway greenhouse effect we mentioned earlier. Now, let's talk about Earth's magnetic field. Generated by the swirling motion of molten iron in our planet's core, this invisible shield protects us from harmful solar radiation. Without our magnetic field, life as we know it would be impossible. The solar wind, a constant stream of charged particles from the Sun, would strip away our atmosphere, leaving Earth barren and lifeless, much like Mars. Finally, let's discuss the role of the Moon in Earth's habitability. Apart from influencing our day-night cycle, the Moon also plays a crucial role in stabilizing Earth's axial tilt. Earth's axial tilt, or obliquity, is responsible for our changing seasons. The Moon's gravitational pull helps maintain a relatively constant tilt of around 23.5 degrees, ensuring that our climate remains stable and predictable over long periods. If we didn't have the moon, Earth's axial tilt would vary wildly, causing extreme climate fluctuations and making it much more difficult for life to adapt and survive. So there you have it. Earth's perfect conditions for life are the result of a complex interplay of factors, from our planet's unique position in the solar system and the formation of our atmosphere to the presence of plate tectonics, a strong magnetic field, and the stabilizing influence of the moon. It truly is remarkable how all these factors have come together to create the perfect home for life as we know it. And as always, if you like this content, share it with your friends and subscribe.